What are we doing tonight?
More logarithms.
Okay. Good. I love logs. What do we got?
3 natural log 5x equals 10.
You're going to have to speak just a little bit louder. 3 natural log of what?
5x equals 10.
Like that?
Yeah.
Okay. It's the first step. In other words, our plan here is to isolate the natural log of 5x and then convert it to an exponential expression and solve it that way. So what's the first thing I need to do to isolate it?
Divide by 3 on both sides?
Yeah. So now I got natural log of 5x equals 10/3. Now what?
E on both sides?
Well, if I convert this to an exponential expression, what would I have?
5x. So you don't want to do that.
Convert this to an exponential expression at the top. If I said natural log of 3 is equal to 7, what would you say? Oh, hold it. I can't do that. I got to do this. What would you say?
E7 equals x?
E to the 7th power equals x. Correct. Okay, so do the same conversion down there.
10/3.
Hold on. There's an E. That's where we want to start.
E 10/3 equals 5x.
Okay. So x is equal to e to the 10/3 divided by 5. That's just a number. Remember, e is just a number like pi. So you can always get this number. Okay, what else?
Log base 3.
Log what?
Base 3.
Log base 3
Yeah.
of
X minus 5 plus log base 3 of x plus 3 equals 2.
Okay. In order to solve this, we've got to get it down to one log term. Okay, in other words, if I can get log base 3 of something equals 2, then I can solve it by doing the same thing we did with the last problem. But first of all, I got to narrow it down to one log term. How do I do that?
Since they have the same base, can you just say log base 3 of x minus 5 times x plus 3?
Correct. Okay. So I'm going to compress it. And that is x squared minus 2x minus 15. In other words, I multiplied them together. Okay, now what? Convert it to exponential.
Natural log.
No. Convert it to exponential expression. When I say convert a log to an exponential expression, the way I remember it is it's the number on the far left raised to the power of the number on the far right equals whatever's in the argument. Okay, so it's real easy to convert it to an exponential expression. We still have to solve it, but let's do that. So we have 3 squared equals x squared minus 2x minus 15. Now, how do we solve that?
So 9 equals x squared minus 2x minus 15.
Yeah.
Subtract 9 and do 7.
Okay, what next?
Factor.
Okay, what's it factor into?
Negative 6 and 4.
Okay, so my two solutions are what?
X equals 6 and x equals negative 4, but we can't negative 4.
Well, we need to plug in both of those into this, not this one, but this first one. A lot of times, if you plug it into the compressed expression, it will pass the domain test. But it has to pass the original problem. And you're correct, the negative 4 solution gives you a negative number right there, and there, as far as that goes. So negative 4 violates both domains. The positive 6 does not. That'll make that 1, that'll make that 9. No domain violations with the positive number. So that's the answer. You got to be a little careful. It's not always just the negative numbers that violate the domain. I could have had a negative x right there, in which case the positive 6 would have violated the domain, and the negative 4 would have been fine. The negative 4 would not have passed this one over here, but I'm just pointing out a case where you can't just automatically throw out the negative answer. You have to plug it back in and make sure that the argument is negative with that negative answer. Okay, what else?
Log base 3 of x plus 1 minus log base 3 of x equals 2.
Okay. What's the next line?
Log base 3 of x plus 1 divided by x equals 2.
And the next line?
3 squared equals x plus 1 over x.
And the next line?
9 equals x plus 1 over x.
Okay, and then the next line?
9x equals x plus 1.
And the next line?
8x equals 1. And x equals 180.
Okay. And let's check that. Well, that looks good. It doesn't violate that, doesn't violate that. Can you take the log of 0?
1.
Huh?
1.
No, you can't take it. It violates the domain. This number, the argument, has got to be a positive number. This is more restrictive than this. The square root function, x has to be greater than or equal to 0. In the log function, x has to be greater than 0. Okay? What else?
Log base 2 of x plus 2 minus log base 2 of x minus 5.
X minus 5?
Yeah. Equals 3.
2 or 3?
3.
Okay. Next line.
log base 2 x plus 2 over x minus 5 equals 3.
Okay, they're not being very imaginative here, are they? What's the next line?
X plus, wait up, 2 cubed.
Hold it, what?
2 cubed.
Okay, that's 8. Okay.
And then
I spoke too soon. I thought it was 3 squared again. It's 2 cubed. I almost made a mistake. Equals x plus 2 over x minus 5. You know how to solve that? Now let's go ahead and go to the end, because the key part on all of these is making sure that we don't violate domains. So what's the next line?
8 x minus 5.
Next line?
7x minus 40 equals 2.
That passes both domain tests. Now, it's possible that they'll give you a log equation that does not have a solution. It's pretty easy to come up with a log equation that just doesn't have a solution. If I put in a negative number here, it probably eliminates the solution. I don't know. I don't know what it would take, but you don't always have a solution. In other words, you have to take your answer or answers, plug them in, and if a single answer violates both domains, then you have no solution to this problem. But the thing I cannot stress the most is the fact that you cannot use this to check your domain. It's not x plus 2 divided by x minus 5 that has to be positive. They both have to be positive. Notice that if that were negative and that were negative, this quotient would be positive, and it looks like it would pass the domain test, but it doesn't. You always have to go back to the original thing to check for domain, which tells you something. It tells you that these are not identical. When I take this log equation and I compress it into this, these two things are not identical at all. It's just something you can do. You have to be very, very careful with domain. It's the best way for me to explain it. I can't really explain why. I mean, I know they're not the same because of domain, but it's hard to explain why. What else?
2 log base 3 of x plus 4 equals log base 3 of 9 plus 2.
9 plus 2?
Yeah.
Expand the left part of that. By expanded, I mean put the 2 up there instead of down there. Okay? You see that you can do that? In other words, whenever you have a number in front of the log, you can always move it to the exponent of the argument.
Mm-hmm.
Now, what can I say? Since I have the log base 3 of this entity equals the log base 3 of this entity, what has to be true? The arguments have to be the same. Think of it as dividing both sides by log base 3, even though that's not at all what we're doing. Okay? What I'm saying is if the log base 3 of A equals the log base 3 of B, then A equals B, by definition. Understand?
Yeah.
So, x plus 4 squared equals 11. And then just solve that quadratic that's going to result from that. And one of those, let's do it. Let's not stop yet, because I made a major mistake here. Let me go back and rewrite this. I did what I've been telling you exactly not to do. Okay, so now I can say x plus 4 squared equals 11. So that's x squared plus 8x plus 16 equals 11. So x squared plus 8x plus 5 equals 0. Notice this does not factor. Solve for x. Using the quadratic formula. I can't understand what you're saying, otherwise I'd be writing it.
Negative 8 plus or minus root 8 squared minus 4 times 1 times 5 over 2.
I can factor a 4 out of that. So it's minus 8 plus or minus 2 root 11 all over 2. And so that changes it to a 4. It takes away the denominator. So that's my answer. So my two answers are this, okay. This is our original problem. I need x to be greater than negative 4, otherwise this will be 0. Okay? So x has to be greater than negative 4. Which of these answers is no good?
The second one?
Yeah, because this one, negative 4 minus something else, that's going to be less than negative 4. So that violates the domain. This answer does not. Square root of 11 is 3 and change. So minus 4 plus a positive 3 and change is going to be negative like 0.8, which is fine. Doesn't violate the domain. So the answer is that expressed like that. Not as a decimal, but minus 4 plus root 11 is the answer for x. Now, let's go back and notice that if I tested my domain out there, it's all positive. In other words, because I'm squaring it, it doesn't matter what x plus 4 is. If that's negative, I'm going to square it, and I'd be taking the log of a positive number. So if I'm checking my domain there, it passes. But if I'm checking it at the original, it does not pass. One of the answers doesn't pass. Both answers pass this part. But just always remember you got to go to the beginning. Now, I'm trying to think of whether there was another way to do this. I don't think there is. I'm not quite sure how to do this other than exactly what I did. I can't divide both sides by 2 as a first step. I've got to get that 2 as part of the argument, like this. So that first step is the only one I can do, because then I got log base 3 of something equals log base 3 of something else. This something is equal to that something else.
Log base 2 of x minus 6 plus log base 2 of x minus 4 minus log base 2 of x equals 2.
Okay. Compress all three of these into one log.
X minus 6 times x minus 4 all over x.
Okay. Express it exponentially.
2 squared equals x minus 6, x minus 4 over x.
Multiply both sides by x. Solve that quadratic. Let's see if that factors easily. What do I get? I get x squared minus 14x plus 24 factors into x minus 12 times x minus 2. So my solutions appear to be x equal 12 and x equal 2. Let's see if all those work. Which solution doesn't work? Of 12 and 2. Those are my two solutions.
2.
Correct. 2 because it violates that. Notice that none of them violate this. That turns out to be positive with all of them. So the only solution we have is x equal 12. And that's the way you do these. Step by step. The only mistake that's really possible to make is checking the wrong step to check the domain violation. All right. Mina, I got to run. I got a 7:30.
All right.
All right, have a good week. Let's see, we're scheduled for Thursday at 7. Talk to you then. This time I'll just text you the meeting ID, and you'll have the icon, the GoToMeeting icon on your desktop. So just double-click that and put in the meeting ID, and you'll be in business.
Okay.
All right, bye-bye.